Yeah, good morning, everyone. This is Andy Fang and my friend Jun. So two of us, we're going to give you an update about our recent effort, try to bring the deep learning and Hadoop together. Just wanted to set the context. I think last year at the Hadoop Summit, I gave you guys some overview about our effort, try to bring machine learning on top of Hadoop. So this year's talk essentially is a continuation of our journey about what we are doing, on top of that thing. So the talk, I think, we tried to start with explanations why deep learning is important, from a Yahoo point of view. And then also we wanted to explain why deep learning and Hadoop have to come together. And then we're going to dive down into a particular technology we have been working on called Cafe on Spark. That one essentially is to try to bring in one of the most popular deep learning framework and onto a Hadoop Spark environment. And along the way, we're going to give you two demos. One is a demo about how the deep learning, what is the capability of the deep learning. Then the second is how you're going to use the Cafe on Spark in a public cloud, such as EC2. So let's start out with the deep learning, right? I think that some of you get the demo in the keynote this morning about face recognition or something, right? And what's in the nutshell, deep learning is a branch of the AI. It tried to simulate how our brain learns stuff. So you have all the neurons in your brain. In the simplified world, in the deep learning, we model your brain's activity by the layers of neurons. So you have your input data goes through the input layers, so set of neurons, and they get progress a set of the multiple layers, and doing the nonlinear transformations. At the end, gradually you learn high-level abstractions, such as like this morning, it found out who is the person is. And then in typical case, there are many layers involved, and then you have millions of parameters you need to learn. So the way we learn is like you do the forward, calculation about starting with some parameters, learn what's happened, and then at that once you have some result, then you compare with your prediction against the ground truth. Then you kind of try to apply gradient descent and to reduce the errors. We keep going this forward, backward iterations. At the end, we will have precise models to describe what's the object we try to understand. So here's an example, one of the use cases at Yahoo that are for online photo service. So until recently, many of the time, you upload lots of pictures. A very simple way to organize your picture online is by dates. But as you have more and more pictures, and many times you find it's really harder to find a particular pictures. Especially many of you may behave like me, it's really hard. You do not want to spend enough time to give the tag, so that you could do an easy job to search later. So what we wanted to do here is, we learn what's in those pictures by deep learning. So once you learn those, then we could organize your pictures by the categories. So last year, we released a feature called the magical view in the Flickr, right? So what's going on here on the left-hand side, there's a bunch of the categories. And then as you go through those categories, you will find the corresponding set of the picture you have on the right-hand side. So this is, I think, what I'm showing here is some of my pictures I was in there, I think, with some outdoor activities. And here are some of my pictures in front of some buildings. some other pictures in a particular, architecture background. So I think this is a one, capability, right? Certainly, once you be able to understand those things, you could do much beyond that. So here's another example. Like, assuming many of you use the weather app. I think many of the weather app look like that, right? It gives you, information about what's the weather condition at particular locations. So instead, at Yahoo, we decided to leverage our deep learning capabilities to give you a slight, different experience of your weather app. So what we have here is leverage the pictures that we have on the Flickrs, and also try to find those pictures really looks beautiful. So instead of have a human editors to select those pictures, we have deep learning do the job for us. And certainly, in order to do that, right, you need to understand, the timing, all those things. Then also we need to understand what's the inside the picture, right? If we in a clouded conditions, you want to have a picture with a cloud behind it. If the raining time, you may want to have this picture with the raining on it. So, for example, I think I would ask June to give you a demo to demonstrate, how the deep learning could work.
Sure. This tool is called the Vision Kit. It is actually, is this thing working? So this is developed by the Yahoo Vision machine learning team. So the idea is this: these days, people take lots of pictures, and if you are like me, I don't tag the pictures. So you just take the picture and upload it to somewhere in a cloud. In my case, maybe Flickr. So, I mean, but of course, when you look for the picture, when you actually search for the pictures, you actually use some tag, right? You say you went to Yosemite some while ago, and you want to get all the Yosemite pictures, for example. But you don't actually tag them. So the idea is this: we're gonna tag for you. So you upload the picture, and the algorithm will analyze the picture, and we'll figure out the location, the people, and all the stuff like that. So in this. Actually, yeah, okay, right. So if you see here, there are 3 pictures here, but there's more actually hidden. So what I'll do is I will just drag and drop a picture here, for example, and put it here, and it will do some analysis. So a couple things. So first of all, it's a dominant color. So this is relatively easy. You don't need to use machine learning to do this. But the auto tags, basically tags, the algorithm analyzes the image and figure out what category this image belongs to. So for example, in this picture, it belongs to outdoor. So number actually is the probability, basically the score for that particular category. So this nature and rock. These all look reasonable because it is an outdoor picture. There's nature related to nature, and there are huge rocks here, and also other stuff. Architecture, lighthouse, and there is a lighthouse here. So this basically gives you all the relevant tags, so you don't have to tag yourself. Next time when you search for lighthouse, this picture should show up. And also, if aesthetics basically says, is this picture beautiful or not? This one looks pretty good. So NSFW. This is basically not safe for work. This one actually pretty safe. So okay, there's no faces, no people here. So just a bunch of similar pictures, basically, looks like this. So with maybe water, sunrise, cloud, and stuff like that. So this is the one example. So next one I will show you. This is another one. People like this one. so we know who they are. So the tag says their faces. Of course, there are two peoples actually, three faces, and this is a group shot, and people. Yeah, so a bunch of things related to this picture, and it's not so beautiful. I don't know why, but it's safe for work, and the faces it identifies three faces. Of course, it knows the people. They're the celebrities. So this is for the people. So then we have another one. I want to show you another one. So these pictures are all safe, safe for work. So there's one not that safe.
I think we're going to. We are going to the right direction.
Okay.
You found it.
Here we
found
go.
it.
Okay. This is still okay, right? So face, people, indoor. Yeah, these are right. So there's some categories I don't quite understand. There's a garment, and there's a sportswear. So I guess I don't know what kind of sports this is, but it looks interesting. It's okay. It's not very beautiful, but not. It's somewhere in the middle. So this one actually is not safe for work.
But close to.
Yeah, it's close to that that end. So if you get a triple X, that's pretty bad. So you recognize one face, and I guess that's it. I'll leave that like this.
Okay, I see. Anyway, so that's the example about how the deep learning could work for you, right? So now let's try to understand what's behind it. Can we switch? Okay, so in order to do these things, what we are really doing is doing the deep learning using the off-Flickr data sets. So if you think about it, so I mean, we are fortunate, Flickr is a decent, popular photo service. So we have over 10 billion pictures at hand. And every day, there are about over 7 million pictures that get uploaded. So this is an outstanding opportunity for deep learning, right? So then we just needed to do is, using those data sets, apply the deep learning, come up with the models, and then even in our particular case, we using the deep learning to extract the high-level features, then apply traditional machine learning algorithms to come up with like a tag, say how beautiful the picture is, how safe for the work on, all those things, right? And then we just apply the model against all those pictures. So the way, in order to do all those things, because the large number of the, data sets we have, we apply the deep learning, big data technology like Hadoop, Spark, and Storm. You could find all the details over the other side, but I mean, that's the power of how you bring the deep learning and big data together. So here's this is the one story I wanted to give to you here. So one was, so before we started the deep learning, we were working on other things. We did not know deep learning at all. And our Flickr team has been doing the deep learning at cluster, let's call it the deep learning cluster. So they're using so here's the logic as the picture is, right? They're using our Hadoop Spark cluster to prepare the data sets, sending over the data sets for the deep learning, come up with some models, and then apply the deep learning model in the other side. So we keep moving the data back and forth kind of things. I think they did this job for about 2 years after our acquisition of a company called IQ Engine. So then it was from a productive point of view, they run into all those headaches, right? Moving the data, set up the machines. The improvement of the deep learning model was not getting as far as they wish. So then, at that point, after many discussions, we thought, we know system, we have a team who really know deep learning, so why don't we bring them together? So that was essentially the motivation of all that effort we are reporting here. This slides essentially was the similar slides I given last year. The only difference here is we are putting the deep learning on top of in the picture. So I wanted to just mention two sides. One is from the Hadoop cluster point of view, we make some enhancement here, right? Until last year, we only have a CPU in our cluster. Now we added the GPU in it because for the deep learning, it's really quite a lot of the mathematical calculations. So the GPU is critical for us. And then second is during the deep learning training process, there's a lot of data need to be exchanged. So to support that, the large amount of data movement between our nodes, we decided to introduce a high bandwidth network interface, InfiniBand. So that's like our enhancement of our system infrastructure level. Then on top of it, we decided to do, say, let's have a deep learning framework so that our scientists could do their job. So at that point, we looking around, there's several frameworks available. Among them, one of them is called Cafe. That's why we're going to talk about it here. It has been a relatively mature compared with the TensorFlow from Google. And it is, I think, in the vision community, this is the best, I think, the most popular framework for the vision community. And it is certainly the most heavily used framework at Yahoo at this point. So we decided to make this cafe available on this our Hadoop environment. So we have been working on it, since last summer, about a 1 year effort. So in the early this year, we decided to make this cafe on Spark available as an open source. So it is, just a continue our tradition like Hadoop. We make the cafe on Spark as an Apache 2 license. And it enables you to do the deep learnings, on CPUs or GPUs, or we would encourage you to have the InfiniBand, but if you have Ethernet, you still could do the job. And then one of the important things for us is that we really want to make this thing really easy for people to do their job. So I think the easy deployment of those things are very critical for us. So for the people who wanted to understand it, cover the architecture, this may be the only slide that you care. Right, so what we are doing here is leverage the Spark as the mechanism to find where the data is and to perform the training where the data is. So in this case here, so we launch a Cafe on Spark job on 3 nodes. And then say, all the data sets is sitting on those 3, based on the HDFS, those 3 nodes sound like a good place, say where the data is. And we launch the Cafe engines on those nodes. And then what we do is for each of those nodes, they're going to keep picking up a mini batch for their local partition of the data set. So at that point, you will have some, your local version of the model, right? Then what is important here is then we exchange the model information with one another. So if for the people who may care, we using this, we have a MPI interface using the GPU direct by the RDMA interface. So essentially what we are doing here is bringing the Spark architecture and the high performance computing architecture together. So we're using the Spark to bring the computation where the data is. And then we're using the HPC architecture to make sure is the performance of this architecture going to be as efficient as your dedicated deep learning cluster. Right. So after the many iterations of the training, at the end, we have a model, we put it into the HDFS. Then you could use the model to do whatever you need. So we did some quick benchmark at at the beginning of the project. So I think this line here is the x dimension here is the number of hours you do the training for a simple network, and then the y dimension is the try to indicate how the error rates has been decreased over time. So the top line over there is using 1 GPU. So if you notice here, like after this 40 hours of the training, we have the accuracy about 60%. Right? That's still a long way to go, And then on the other hand, if you look into the other line there, I think within the line, I think was which one is? Like if we look at the 2 nodes ones, that's like within about the 6 hours, you have the 70% accuracy. So if this thing could go in for a while. And so we estimated, it be able to leverage this, high bandwidth of using our softwares, you will be able to achieve, significant benefits for your speed up. So the reason we have the estimate instead of have the final number, because our Flickr team heard about this rumor, this thing is coming. And then they found it's really easy to use. So then they decided to say, you guys stop at the benchmark, we need to do the real work. And then for their benefits, it turned out, I think, as I will explain in a few minutes, to using the Spark, Cafe on Spark is really easy. For the people who know this Spark, there's one command to launch this thing called the Spark submit. We enable you to do the training in your single node, multiple node, with a different kind of network as you wish. Then more specifically, when you launch the job, you need to specify like how many executors you want, how many devices with the CPU or GPU you want for each executors. Then you specify where the configuration file of your Cafe deep learning configuration you're going to apply, then do the training test or feature extractions. And for the Cafe users, we decided to make essentially enable them to leverage their existing configuration files. The only thing they needed to modify here is they needed to put their data sets on HDFS if they wanted to leverage the larger clusters and specify what is the format of the data format is. For many of the Cafe users using LMDB, we basically go ahead using that thing. And for the others, they have the multiple different other formats we support. And then for the users who like to write a program, the API for the Cafe on Spark is very simple. So here, logically, that's it, right? So what we have here is enable you to go back. So here's the basic API, right? Enable you to specify what your configuration thing is. After that, you say, OK, I wanted to access the training data sets, performing the training. And then you do the same thing for your test. And then you wanted to get the feature out of it. And then what we even wanted to enable you to do is that whatever the result from the deep learnings, be able to directly apply to the non-deep learnings. So you could using like a Spark MLlib logic regression algorithm to do the other step if you wish to. Then for the Python users, we essentially have the similar API. So you could using like a IPython notebook, whatever you wish. You could be able to look into your network, do the training, do the test, look at our features, like data frame type of things. So then once you do those things, then for the Spark users, and during the training process, you could look into your Spark, a dashboard to see the progress it's making, all the many jobs get launched. And then you could using the cafe log to see the progress it's making. If you're looking very deeply, it was explaining over there is the log indicate how many iterations you have done, what is the log, the loss you still have. So I think I will ask June to give you a real demo.
Okay, so let me switch to.
Good.
So basically, I'm trying to show you how to do deep learning in about 10 minutes. So this is the MNIST, handwriting recognition exercise. So this is like a hello world kind of program for deep learning. So let me just explain the setup. So we launched 2 instances at Amazon EC2, 2 GPU nodes, and each GPU node has 1 GPU. So basically, we have 2 GPUs on different nodes, and we want to use them jointly to train a model. So let me start. So basically, I try to fill up this blanks, basically. I fill up all the blanks here, and we'll look at the data set, and we'll train the model, and we'll take the model and do some validation to test how good the model is, and then we can extract the features from image. Then we use that feature, feed that feature to a different classifier. In this case, it's a logistic regression classifier. Then we can do a better. We can do another layer of machine learning. So that's the basic outline. So let me start with the basic stuff. So let me load all these libraries. Okay. Is it Control Plus?
Good.
Is it better now?
Yeah.
Okay. So first step is, if you're familiar with Python, you basically loads all these modules. Then let's take a look at the training data. I have all the scripts written here, so it's my cheat sheet. So, but it's pretty simple. So what this does is basically, you read our file is the data file is a data frame and it's in Parquet format. So I load the data, and I want to show you the first 5 images, and you can see these images are 72104. So it has 3 columns: one the index, 1 column is label, actually the ground truth basically, and this is the image. So the goal is to read the image to figure out what number it is. So basically, you can think of it as a classification problem, and there's 10 categories, and you're trying to figure out which category this image belongs to. So that was the data set. Then, so we're going to use a neural network to do the classification. So I'm here. I'm going to show you the topology of the network. I guess you start with the data. You get the input data, then you go through different layers. There's a convolution layer, a pooling layer, another convolution layer, another pooling layer. And there's another convolution here, and another pooling here, and there's an inner product layer, and 2 inner product layers, and then you get a soft max with the loss, and you calculate the accuracy here. So that's how that's how this network look like. So let me start training. So I'm going to just copy this and I'll explain later because the training will take a little bit of time. It will take about 3 minutes. So let me just copy all these training related stuff here and explain why the training is ongoing. Okay, the last line here is actually the training. So previous lines are setting up the environment. So now the training is ongoing, so let me explain this. So first line basically say you want to get a Kafka Spark instance. You get an instance of the class, and you provide an argument. So argument is firstly you need to specify the network and all the solver parameters. Like how many iterations you want to do, how often you want to print out the result, stuff like that. Then model is where you save the model. So by the end of the day, the training will generate a model, and this is where you put it. And we put it on HDFS. And then you need to specify how many devices per node. In our case, there's only one GPU per box, so it's just one. Cluster size, we have 2 nodes, so it's 2. And the connection, right now we're using Ethernet. At Yahoo, actually, we use faster networking, so we use InfiniBand. Then you get this config, then you get a source, and then with that source, you call this train function, and you'll start training. So why the training is ongoing? Let me take a look at this Spark GUI. So basically, this thing can track the whatever the job is running. So right now we have one job is running. So let's take a look. So detail the UI. So for those familiar with the Spark, okay, it's a little bit small. Let me make it larger. So it has multiple stages, basically multiple tasks, and multiple jobs. So it basically goes in multiple iterations. Then you can see all these. It has gone through a lot of iterations already. And so if you want to, let me refresh this because it's 24 already. So yeah, it's almost, I think about 30 if you should finish. So while it's running, the training is running, let me go back to here and explain what's going on here. So when we train, actually, we have two nodes, and each one runs this network. And you have data basically going through this network, and you're going forward. You calculate all the all the values. You calculated the loss. Then you go backward to calculate all the gradients. Then you add all these. You average each node, calculate the gradient, and you average them, and then broadcast to everybody else. So that's how it works. So it is a synchronized training. So let's see. Oh, training is finished. So we have a model now. So next step is let's take a look at how good the model is. So again, we need to set up all these variables. So this line actually tests, So what we did was we take the model and we take the test set data and we run through this model and let the model decide what the number each image corresponds to, and then we can take a look at the final result. Okay, it's pretty high accuracy. It's about a 99% accuracy. So this is a pretty good result. The next thing we will do is feature extraction. So So let me explain what a feature extraction is. So you get an image, and then the final result is going to be a number, right? You take an image and you say this is 1, this is 2, or 0. But a lot of times you don't care about the final result. And I mean, you want to use some kind of intermediate result to represent the image, but you don't want to take the whole raw data because it's very, very large. And you want to just extract the useful information out of the image. So that's why I call it feature extraction. So once you extract the feature, you can use it for other classifiers and other machine learning algorithms. So the feature I used here, let me see. So what I did was I selected a few features, 3 features. So one is accuracy. I want to know the accuracy of each node. I want to know the IP1, IP2. I want to know the label. So IP1 and IP2 actually are the node here. This is the IP1 and this is the IP2. So these are the inner product layer, the output of the inner product layer. So as you can see, the IP1, the IP2 are basically, these are vectors. So these vectors represents the image. And it's like, compressed, compressed value of the image. But it has all the information about these images. So next thing I will do is, so next, since I already know all the scores, so these IP2s, you can think of they are the scores, and from the scores you can figure out which category actually these images belong to, and with that you can see that this prediction, you pick the maximum score, and the maximum score, the index of that maximum score is a prediction, and they match pretty well. So next, I will show you how to do this logistic regression. So again, we need to load up a bunch of modules. And I will just do all of them together.
Yep.
Just to save some time. So what this does is you concatenate two machine learning algorithms. So the first one is the deep learning. The second one is regular logistic regression. So what you do is you extract the features from the images, and you feed that to logistic regression. Then it will figure out what these images are, and here's the result. So in this way, you can have very powerful algorithms. Basically, it's a concatenation of multiple algorithms. So I guess that's the end of the demo.
Okay, cool. So I think we are running out of time. I think let's see. So I think we continuing enhance the Cafe on Spark. That the new feature is going to be released in coming weeks, including the validations, the LSTM support, and others. And I think there are several other implementations for the deep learning on Spark. And the architecture is very simple-minded. And as a result, as the driver, we become the hotspot. And then, so anyway, but you are welcome to evaluate sources, the other alternate solutions when you consider different solutions. And I think in the takeaway, deep learning, I assume by now you believe, have some sense about why deep learning is important for us. And also you have a little bit of understanding about how, the flavor of Cafe on Spark. And it has been used in our production for, several quarters now. it has been a real impact for our business. It's up to you to figure it out whether it's useful for you. But I think one thing we could guarantee you, this is using Caffe on Spark, the deep learning should be really easy. If you know Spark, you should be able to do the deep learning. And you could find all the additional information of the Caffe on Spark from the GitHub. And if you have any questions, you're welcome to send it to our mailing list. Thank you.